But also it enables us as T-SQL people to reach over into Hadoop ecosystems to get access to data using the T-SQL language that we know. So we'll do a complete walkthrough of loading data in a fast parallel way using Polybase as well. And then if there's time, as I said, we've never really done any talks on SQL Data Warehouse like this, so I've got no idea if there will be time. But we'll look at the Azure Data Factory integration and also the Azure Machine Learning's integration with SQL Data Warehouse. So what is big data? Specifically, what is big data in terms of SQL workloads? So these are a few, I'm going to just go through three key workloads. These are all real companies. I've removed their names, but the oil and gas exploration business. This is one of the top 4 petro companies. They're gathering data at about 1.5 terabytes a day, and it's flowing into Azure SQL Data Warehouse APS. This is data coming from all of their seismic mining activities, looking for oil. The oil exploration is one of those, the winner makes everything. The person who finds that oil first is the person who gets to mine that oil forever. So being able to get that data into a system, which a lot of it turns up into the a big data Hadoop system, and then the stuff which needs to be queried with very fast request responses gets moved over into the data warehouse, where it's inside a relational system using in-memory column stores for very fast request response, much faster than you can get with a job-based system. Smart utility management. So in the US, there's a lot of legislation being put in place on energy companies to be more efficient. And for energy companies, it's all about sizing to peak load. And if they can manage peak load to be less, there's enormous amounts of money that can be made inside the energy business. So we're working with some of the big energy utilities, which are now putting smart sensors all over their geographies. And that data is flowing in this case, at 100 terabytes a year. These are the kind of data sizes that begin to break down inside a single box, which you just keep scaling and scaling. And this is where the MPP technology begins to take off, and which is what we have in SQL Data Warehouse. Finally, the data warehousing team is down in California, close to Los Angeles, and there's a lot of car accidents in Los Angeles. I don't know if you've ever driven around Los Angeles, but it's one of the most unpleasant things. I guess we drive around Bangalore here. That's not particularly pleasant either. But there's a lot of work to instrument the roads, and then and the government, the councils are working on that, and then allowing companies to come in and see that telemetry, and then reroute delivery vehicles and businesses with vehicles on the road so they can avoid congestion. So again, this is the same kind of pattern, very large amounts of data coming in, but the time to insight where you need that fast request response, it's still the relational world that gives you that, and blending that with MapReduce worlds of Hadoop. And that's what we're doing. So when we hear the words big data, and this is one of the key slides I really want, as SQL geeks, I really want you to take home with you. This is a report from 451 from 3 months ago. And what it's doing is looking at where the money is going to be spent over the next 5 years in the big data world. And when we hear big data, it's often so much synonymized with Hadoop and that kind of ecosystem. But in actual fact, where you see where the money is, all of them, we can't quite see, but this is the relational tradition. This is the relational SQL data warehousing business up until 2019, and this is the Hadoop data warehousing business. It's the SQL relational data warehousing business where the majority of the spend is going to be for the next 5 years, and that's what I want to talk to you about with Azure Data Warehouse. So, introducing Azure SQL Data Warehouse. So it's the first fully managed data warehouse from Microsoft, and it introduces some very unique concepts which we believe no one else on the planet today offers. It's based on the massively parallel processing system. We're going to spend some time understanding what that means. And then it has a couple of unique features in that instantly you can turn up the amount of compute that you bring to your data warehouse. So if you want to speed your queries up at the end of the quarter or the end of the month, you can just bring more compute to the data warehouse, and we'll look to see how you can do that. And with that Polybase integration, it integrates both the relational, but also the traditional MapReduce ecosystems as well, all into that T-SQL language, which we know so well. It's powered by the cloud, so there's no large CapEx that you have to go out and put up front. For $1.40, you can get going, and we'll get going. I'll show you how to do that. And we've integrated it with all of the Azure services that make sense in the data platform. So specifically, it's completely integrated with Power BI, and I'll show you that. And we've got good integrations with machine learning and Azure Data Factory. And we've got a very local competitor to us up in Redmond, and that's Amazon. And before we saw some of the comparisons between Azure Data Warehouse and Redshift. So they've been out for a couple of years, and we were fortunate that we got some time when we were designing this to really study what data warehousing loads tend to shift. There's times of the month, times of the quarter, the year, where you want a lot of compute. And when you're not doing that, you don't want to be paying for all of that compute. Sometimes you might not want any compute. But with the Redshift market, we could definitely see that customers were struggling with the fact of having to pay very, very large upfront fees for compute that they weren't needing. And the other thing is with Redshift, we saw that customers were having to buy compute and space storage together. And there's not really any need to have to tie those two together, but the architecture they chose has forced them to. We've gone off and fixed both of those. So storage is completely disaggregated from compute. You can put terabytes, petabytes into your store and have no compute turned on at all if you want. Or vice versa, you could decide to have a very, very small amount of storage, but you might want to have hundreds and hundreds of cores attached to that because you're doing very, very intensive computation. The choice is yours. So you can make this, you can bring as much compute to this storage as you want, or you can just turn it off. Elastic scale. We have this concept of a data warehousing unit, a DWU. We'll go into a bit more details of what that is. It's on a simple slider, and you literally can slide the amount of compute that you bring to your data warehouse whenever you want. So at the moment, this is running 3 slices. If I slide the compute to 1,000 DWU, it's going to run 10 slices. We call it DWU, data warehousing units. That's what we call it inside the engineering. So if I ever say DWU, I mean this data warehousing units. The data warehousing unit concept that we created has enabled us to abstract you away from the details of what the clock speed of the CPU is, what the speed of the disks are. And it guarantees you an amount of performance that we will keep consistent regardless of what happens with the underlying hardware. As the underlying hardware gets faster and faster and faster, we will certainly make it possible to have even more DWUs for an individual database. At the moment, you can have up to 3,000 DWUs for a single database, and we plan to have up to 6,000 by the end of the year. And then pause. If at any time you just don't want to be paying for any compute with all of that storage you have in your data warehouse, you can just hit the pause button, and the compute just turns itself off. At any time, you can come back and turn the compute back on. So we have, when you create an Azure SQL data warehouse, you get two bills. You get the bill for storage and the bill for compute. Compute is by far the most expensive component of that. Storage is really very cheap. So let's get going with a little demo. So the way that we get access to Azure SQL Data Warehouse is just through the portal. Oh, you can't see the screen. I'm going to duplicate. Okay, I'm going to have to extend, but therefore I'm going to have to see what's happening behind me. Okay, so this is the Azure Portal, and you can create an Azure SQL Data Warehouse. bit strange doing this on my back. So Azure SQL Data Warehouse is a new option here. Okay, so you get down to this panel, and it's as simple as giving it a database name. So we'll call it SQL Geeks. That's not quite right. And as you can see, we can decide how big that we want to create this warehouse. Each click along the way is the number of DWUs. We'll just create it at 100 right now. We'll change that later. And then I just need to select a server to attach it to. So it's just a normal SQL, a logical SQL database, Azure SQL database server. We'll use an existing. Okay. There's my server. I don't want to set central. Select that. And then hit create. So in 30 seconds, I've created a Azure SQL Data Warehouse. Well, I've sent the command to go off and create an Azure SQL Data Warehouse. So you've now got a data warehouse that you can bring hundreds and hundreds of cores to. You can scale that up to a petabyte of raw storage, and then if you use the clustered column store, the in-memory technologies, we expect around a 5x compression ratio there. So in 60 seconds, you've got an Azure SQL Data Warehouse that will scale up to that kind of size. It's just never been possible before. Yeah. It is, and I'm working on the India data centers right now. I'm very pleased that in the previous conversation, and also in the demos yesterday, you began to see some of the, hold on, let me just pull this up. Some of the India data centers being referenced. So obviously they're not publicly announced yet, but they're coming very, very soon. So yeah, we're working on all the very final checks there. So we do the big GODR tests, and they're all going on right now. So yes, you will be able to create these inside India very shortly. So this is, and actually, it's a good question, because related to that, the underlying storage that we use is the Azure Blob storage. So I said you get two bills when you create an Azure Data Warehouse. You get your bill for compute, which you can scale and pause or just turn off, and then you get your the bill for storage. Storage, we use the RAGRS blob storage type, which means that it's read accessible in the remote storage area, and there is a remote copy of it. So there's 6 copies of all of your data. So in a disaster recovery case, you can recreate the Azure Data Warehouse on the other side of your region, depending on which region. If you're in India, all regions are always paired, and you can get going. Also, you can use the backup, the remote copy, to spin off other replicas as well. Yeah. Yeah. Yes. Yep. Yep. Yeah, absolutely. Yeah, so we inside SQL Azure SQL database, we have a workloads insight team that actually works inside Serbia, and that team we'll work with that team, and our first click stop is we want to suggest to you what DWUs, which we're talking about here, you should have at any time to be able to best optimize your spend. Are we ever going to get, well, are we in the short term going to get to the point where we actually move the slider for you? I'm not sure, because it does have an impact. When you're sliding more compute, the running queries do get affected. So I think what we will do is we'll make it very easy for you to gain insight to what usage is going on inside your data warehouse, and suggest to you what DWU rating you should have. Yeah, we are working on that. So this is what a DWU is, a data warehousing unit. It's, for us, we are taking these 3 metrics and then trying to get them to scan completely linearly. So we have an engineering team just focused on this. So we take the initial scan rates down at 100 DWUs, and then each 100 that you add, the scan rates comes down, the load rates go up, and the table copy goes up. So it's a combination of these 3 values, which is what we're aiming each DWU click stop to be. We are very aware of our competitor across the road. We are determined to be price comparative to each click stop that they offer, but you can also pause this whenever you want and slide it in instantly without having going through a big data shuffle, which you can't do with Redshift. So we're completely laser focused on that. Also, again, this was alluded to in the previous presentation, we have a lot of features because we're SQL Server that Redshift doesn't have. I'm just outlining all of those nice things which we're used to inside SQL Server, we have in SQL Data Warehouse. So you do get stored procedures, you get that right once, used many times, and all the performance advantages of that. We have put table partitioning in already, so as well as the data being distributed across many distributions, which are our internal shards, you can also create table partitions within the shards. We support all the normal collations that you'd expect to support inside SQL Server. And then we also have that column store technology, which is how we expect you really to create all of your tables inside this. And we'll probably make that the default too. So let's look at some Power BI integration. So we are already pretty well integrated with Power BI, and that's just going to get better and better, as you'll see. You've already seen Power BI a lot. Our integration with Power BI is directly inside the portal, so let's just go there. So let's go there. Inside the portal, we have, look backwards. So go back to home. So that our database from before has been created. I've got one over here. So this is a data warehouse I created a little while ago. So what we're going to do here is just, let's insert some data into here. So let's just show you. I'm a bit confused with this. Okay, got it. It's back to front for me. Okay. Here we go. So let's connect. So we're connected to a SQL data warehouse. As you'll see, we're connected to the we're connected to the parallel data warehouse version. So that's an indication that you're connected to a data warehouse. And just going to create the AdventureWorks schema inside this data warehouse, and we'll load some data into it. This is a dimension table. Everything here you're very used to. Hit F5. There's absolutely no change in syntax there at all, what you're used to in a normal SQL database. Here we're going to create, well, just select, there's no data in there right now, just created it. Now here's where you begin to see a little bit of syntax difference, and this is where that MPP concept comes in. Here we're creating a table, but because it's a fact table, we want to spread this data across the distributions which are inside the data warehouse. So we have a new syntax here called distribution, and in this case I'm using hash. So what it's saying is I want to hash this key, and it will produce a unique number, and any other table that also hashes on that unique key will also place its rows in the same distribution. So if I've got data in many tables which is clustered together, I can ensure that the rows which are all related are inside the same distribution inside the data warehouse. So the data warehouse doesn't have to move data between tables to answer those queries. So that's some of the magic sauce happening there. And of course, this is an in-memory, this is a clustered in-memory table as well, using the in-memory column store technology. Really, all tables should probably be created like that, and we'll almost certainly make it the default based on the feedback we're getting. Okay, and no data in there. Okay, so we've created some AdventureWorks tables. Let's just go and load some data. Okay, so the key point here is BCP works with Azure SQL Data Warehouse. So just the tools that you're used to already in SQL Server, they work. But BCP is a client-based tool, as you know. So in actual fact, I'm loading some data here from my laptop. We'll probably run a few thousand rows. And then, I'm not sure why I haven't started. And then